Let's check out the routing table. So what we'll do is we're going to build a network, and we're going to take a look at the route table that we subsequently create. So I'm going to add a couple routers in here, and we're going to try and get some interesting routes. Then we'll take a look at that routing table on R1. So we're going to take a look at what slots I have, and you know we are back in GNS. Now that we're back into routers, I can go back to using this. So what we'll do is we'll do it based off of Wix. So these are the serial connections, or WIC ports, and on each of these we'll do one WIC. Alright, we'll start those up. So now, even though they show green, they're not really configured. They're just showing that the routers have booted up. So I'm not going to go too much into the reasons for some of these subnets. When we get into the wide area network videos, it'll make more sense as to why I'm creating some of the subnets I am. So don't worry too much about that yet. So what we'll do is go ahead and create some subnets for these. Click that icon up top, it'll show the actual interfaces in use, which is pretty handy. So open up my console. I don't even necessarily need to go all the way through this, but it's fine. So I might as well explain it as I'm going through. I'm creating /30 routes because on serial connections often it's recommended to just use the amount of IPs you need, so hence the reason for subnetting. Each of these is /30s are creating a 4 IP block. So one is our network ID, one is our broadcast, then there's 2 usables. So the one usable goes on one side, one usable goes on the other. So that's why I'm going through and doing that. So the next one's going to start with a 4 for the network ID, so the usable would be a 5. If you go back to the subnetting video and try doing some subnetting with /30s, you'll see how that works. Okay. Okay, so that'll work. So give us a few to take a look at. So we are on our first central router here, and I've added 4 networks. So each of these links off of this router is considered a network. So even though it's just a direct connection, it still has to be IP'd and still has to have some sort of layer 3 configuration done to it. So that's why I created these networks. So we have the 192.168.1.0/30, .4/30, .8/30, and the .12/30. And then the usables will be .1 and 2, and .9 and 10, and .13 and 14, and .9 and 10 and 13, 14. So you get the idea. So there's 2 usables, and then a network ID and a broadcast for each. So if we take a look at the route table, there's a number of values that are in here. So we have a route source. In the route table we have a number of codes. Actually, I should mention first. So the codes are the furthest thing on the left, and it'll say whether it's connected, if we configured it statically, or some other reason. Let me add a gateway of last resort while I'm in here. So let's go into a config T. We'll make a quad 0 route, which is my default gateway routes, if I can put my zeros in the correct order. And we'll send that out some make make-believe address. And that's not currently up right now because I don't have an interface for that. So now my gateway of last resort shows up. I added that route, but I didn't have an interface that had that network assigned to it, and it wasn't enabled. Remember when I, at the end of the other video, I said one of the things you have to look for is make sure that your interfaces are no-shut, so they're turned on or enabled. If you don't do that, those routes will not show in your route table. So, you know, I think I was getting ahead of myself earlier. Before we go into all that, let me show this this actually occur. So if I go into serial 01 and I shut this down, that route will now disappear. So my .4 network is now gone. If I no-shut that, it'll come back online, and it'll go ahead and show up in my route table. So you have to have an interface enabled in order for it to show up in the route table. Alright, so back what we were doing. So we have some codes initially. It means directly connected, statically assigned. If we were running some sort of dynamic protocol, that would show up as a different code here in the beginning. Usually it'll be something like egrep or OSPF, so it'll either say D or O. You might see like EX or something like that for an external egrep route. They're pretty common to notice. You'll have the destination network next, so that's the network we're trying to get to. And sometimes it'll also show you the administrative distance. If this is were a dynamic route, it'll show you the administrative distance to that. And then actually here it shows you, because it's a static route, so our administrative distance is 1. It also gives us the metric, so our metric is 0. And then it tells us our next hop. Our next hop is through this IP, and potentially it'll also tell me the outgoing interface, such as this. So when I configured that static route, actually, I could have configured it in this manner. And then also specify the outgoing interface. Okay, I want to select the interface first. Sorry about that. So F0/0, and then the IP. There we go. So now if we go take a look at my route table, there we go. So it'll show not just the IP address of the next hop router, but the interface we're going to leave out of. And actually that becomes more necessary when you start talking about processing in your router. If you do not specify both the IP and the interface, it's going to potentially require an additional lookup. So it's recommended that you provide both the interface and the IP. If you provide just the IP, it has to look up what interface it needs to go out. If you provide both, it immediately knows where to send that traffic to, so it makes things a little bit faster. So that's actually best practice there, to define not just the next hop IP, but the interface itself. So those are some of the fields you'll see in a route table. You'll have the code for the route source, where it came from. Is it directly connected? Is it a static route? Is it dynamically learned? What is the administrative distance? What is the metric? What is the next hop IP? What is the next hop interface? And we have a couple different types here, actually. So the term ultimate route is used for a route that has the next hop IP or exit interface. So in this example, it says we're going to go out serial 02. That would be an ultimate route. This one says we're going out fasteth00. That's an ultimate route. This one says we're going out via this IP address. That's an ultimate route. If it does not have any of that information, such as these two, these are not ultimate routes. These are level 1 routes. So level 1 route in this example is a parent route. So what it is this is a subnet heading, essentially. So it's saying the following subnet is below and available. So basically it's telling us this is a classful address, and there's a bunch of subnets that have been created out of this classful address, and here are the following subnets that are available for that classful address. So that's what a level 1 parent route is. The ones below it that are indented are considered level 2 child routes. So that's the difference there. These really act as headings to your route table. So when you're glancing at it, you can kind of see the indented nature there. It gives you a hierarchy of your route table, so you have an idea as to what you're looking at. It makes your life a little bit easier. When it goes through and matches, it's going to match top down, and it's going to stop when it hits that first route. So theoretically you won't have any routes in here that are duplicates, but if you did, it would match the first one. So once it goes through and checks its route table, if you're trying to get to 192.168.1.13, it's going to see this route and say, oh, there it goes, out that interface, done. It's not going to go check the rest of the table. It checks the very first thing that it matches. And it'll do that through the level 1s, and then if it looks at a level 1 and it says it might match in there, it'll go in and look inside those child routes. So for example, if I have a route come in, a piece of traffic come in that's trying to get to 192.168.5. something, it's going to go through and take a look at this route table, and it's going to say, does 192.168.5. match this? Nope. So it's going to skip this. Does it match this? Nope. So it's going to skip this. Does it match this? Yes. So it's going to go out this interface, because remember, the 000 matches everything. If I have a piece of traffic come in that's trying to get to 192.168.1.5, it's going to check this first entry, and it's going to say, does it match this network? Nope. So I'm going to skip this. Does it match this network? Yep. So I'm going to go check the child routes. So now it's going to go down the child routes and check each of these until it finds the route that matches, and then it'll send it out that way. If you were trying to get to if you're trying to get to a network that was not in this listing of child routes, it would drop the traffic. So if it matches a level 1 parent route but not a level 2 child route, the traffic is dropped. So for example, if we're trying to get to 192.168.1.20 or something like that, it would go through the route table and it would say, does it match this? Nope. Skip. Does it match this? Yes. Let me check. Does it match this? No. This? No. This? No. This? No. No. I'm already checking my child routes. It doesn't match anything in here. I'm not going to go to my gateway of last resort, so let's just drop that traffic. It's junk traffic. So that's one of the things. Once you drill into a child route, it's going to drop it if it doesn't match a child route. So that's where convergence becomes a critical need. When we start talking about dynamic routing protocols, the convergence of your network, having all of your routers have the same routing information for all the networks that are available, becomes critical, because if one of them does not, and it's misconfigured for some reason, then you could potentially lose traffic because it's not matching correctly. And how it and also there's a if this weren't here, it would drop if it didn't match anything else as well. So if we were trying to get to 172.16 or something like that, it would check this, say nope, check this, say nope, and then this wouldn't be here theoretically, so it would just drop it because it reached the end of the route table. Since I have a gateway of last resort, then it would obviously go out that way to try and get to wherever, who else might know how to get there.